Well, now let's take a look here at part G, and this probably is one of the more challenging questions within this section. Let's suppose that 20 light bulbs are randomly and independently selected. What is the probability that 5 of those light bulbs will have lifetimes above 760 hours? Okay, now before we jump in here too deeply, let's quickly go back and remind ourselves of what our random variable was in the last problem. In all these problems here, we've been dealing with light bulbs and their lifetimes. And if I scroll all the way back to the very beginning, we'll see that X represented the lifetime of a light bulb. Notice that in part D, I'm not really asking a question about what is the lifetime of a light bulb. My question is, what is the probability that 5 of the 20 will have this particular property true about them? That is, I want some number of items out of a total number of items to meet a particular property. Well, notice that's kind of strange because that's not even a continuous variable. Take a look. I actually have a brand new variable here. Let's call it y. What y is going to represent, so I'll say let y represent the number of bulbs out of the 20 that last above 760 hours. Well, that's definitely not continuous, right? If I'm saying how many bulbs will last this long, my answers are like 1 bulb, 10 bulbs, none of the bulbs, all of the bulbs. So this isn't a continuous distribution. Of course, what that means is that if I go look here at the formula sheet, I'm not really on this side of the formula sheet anymore. Oh boy, I have to go back to the previous side. And I have to see here, with discrete random variables, how is it that I could determine the number of light bulbs out of a total number of light bulbs that meet a particular condition? Can you tell what column would actually tackle that? What discrete distribution helps me answer that kind of question? Well, you may have guessed it. It's binomial. This is going to help me determine the number of things out of a total number of tries. So out of looking at 20 light bulbs, how many of them are going to end up with this property? Well, to double check that, to make sure that y actually is binomial, let's do the checks really quick. Are there a fixed number of trials? Well, yeah, there's only 20 light bulbs. When I look at a light bulb, are there only 2 outcomes? You could say, yeah, I mean, it either lasts over 760 hours or it doesn't. We're actually told that all the bulbs are selected randomly and independently. And it's really this last piece that's tough. What is the probability of success? What is the probability of getting a light bulb that lasts over 760 hours? Well, to see that, let's flip back to the notes and try to write out some of this detail. I'm going to see here that y does indeed have a binomial distribution. And I know it has n equaling 20, and p is kind of a mystery value. Now, to find that value of p, we need to know what is the chances or what is the probability that a light bulb lasts over 760 hours. So I need the probability that the lifetime of a light bulb is over 760 hours. Well, wait a minute. Lifetime of a light bulb is 760 hours or more. Wait, doesn't the variable x that we looked at up above stand for the lifetime of a light bulb? So this would say, what is the probability that the lifetime of a light bulb is over 760? So, in fact, if I look back at one of my previous parts, specifically here in part D, I can already see that we actually already calculated this. We found that if you shaded above 760 hours, the chances of getting a light bulb there would be 17.27%, or 0.1727. So actually, I'm going to go ahead and just jot this down right here, 0.1727, and I'll just put, this is from part D. So I actually then have my value of p. I can actually just use this value right here. So if p is actually going to be 0.1727, then what we want to compute overall is what are the chances that the number of light bulbs that last over 760 hours is going to be exactly 5 of the 20 light bulbs. So that's a binom PDF where I have 20 light bulbs. There's a 17.27% chance of getting the type of bulb that I want, and I want 5 light bulbs to come out with that property. If I go to my calculator and I type all of this in, I can actually find that I get the percentage, or the decimal 0.1386. So this right here would be my final answer to this question. What are the chances of getting 5 light bulbs out of 20 to act a certain way? This percentage. Now this is kind of a complicated question because you can see that it has a mixture of a binomial and a normal distribution all in one. And this takes a little bit of getting used to. It's really where you have to practice hearing that binomial style question. What are the chances that 5 things out of 20 things are going to do something? What are the chances that 10 items out of 50 items are going to do something? That's pretty much always going to be a binomial question and something we can be on the lookout for.